One of the other types of word problems we said that has a linear relationship is simple interest. Now, simple interest is all we deal with in beginning algebra and intermediate algebra, and we start there in college algebra. Compound interest is much more complicated, and it's something that we hit in the middle of college algebra. Okay, our simple interest formula is that the amount of interest that we earn on an account is the product of the principal times the rate times the time. Okay, again, the principal, that's the amount of money that I walk in the door of the bank with today. Okay, the principal is the amount of money that I give them today. Okay, the interest rate R is usually given to us as a percent. So maybe we're told 3% is our interest rate, or 2.5% is our interest rate. When we put our interest rate into a formula, we almost never substitute the percents in as their numerical percent. Okay, we always need to change in the interest formula our percents into a decimal, meaning 3% is going to become 0.03. Some students for 2.5% say, well, it's already a decimal. Okay, but recall that we need to get rid of that percent sign, which means we need to move that decimal to the left 2 places. So as a decimal, 2.5% is 0.025. The t, in pretty much all of our formulas, all that we'll see this semester, is going to be time. The important thing to remember in our interest formula is time always has years for a unit. So 4 means 4 years, and 9 means 9 years, and 1 means 1 year. If I wanted to only put my money into the bank for 6 months, then I would say that's half a year, or 0.5. Whoa, what's going on there? I have no idea. For t. So t is equal to 1/2, or t is equal to 0.5. Now, fortunately or unfortunately, however you want to interpret that, but all of our problems from beginning algebra through college algebra, the time in all of our problems is 1 year. The author doesn't ever give you anything but 1 year. But if we said how much interest at the end of 3 years, or if at the end of 6 months they'd earned that much interest, that we would make sure that we plugged the right number in for t. Okay. Principal times the rate times the time. If we're talking about our distance formula, the distance that something travels equals rate times the time. Okay, distance equals rate times time. Now here our rates and our times can be in any compatible units that we want to use. And I want to have a conversation here for a little bit about units, because a lot of students in this type of problem mismatch and crisscross units and create things that aren't reality. Okay. So if my rate is given to me in miles per hour, okay, and my time is given to me in hours, then notice that my hours cancel out, and that gives me a distance unit of miles. Okay, which is a reasonable, typically I measure things in miles. It's 70 miles to Wichita. I live 15 miles from Pratt. Okay, miles is a reasonable distance unit. Maybe I'm doing a physics problem, and the speed, the rate is given to me in meters per second. Well, then I need to time my project in seconds so that when they cancel out, that leaves me with meters for my distance unit. Okay. Maybe I am studying the change in the coastline off of Florida or California, and I'm measuring that change. It doesn't change very quickly, but I measure that change in inches per decade. Okay. Then if I'm going to create a nice distance unit, I have to make sure that my time units are appropriate here, meaning I'm going to measure my time in decades, so that my distance is being measured in inches. In many distance problems, your rate is given in something like miles per hour. But your time is given to you in minutes. It'll say 30 minutes later, or 15 minutes later, or 20 minutes later, or 10 minutes later. Sometimes, and I will tell you as a disclaimer that occasionally you can crisscross your units and you can numerically plug in and mix these things together and get the right answer. But what I tell my students every semester, both face-to-face and online, okay, when you are mixing and matching and taking miles per hour times minutes, what you have created is a distance unit called a mile minute per hour. And so if you can sit down with me and you can show me in a reasonable and understandable way how far 1 mile minute per hour is, Ms. Jackson, it's this far, then I'm going to let you use that unit on your homework quiz or test. If this unit makes as little sense to you as it does to me or anyone else on either side of you, then you can't use it on a homework quiz or test. And even if numerically speaking you get lucky and by accident it spits out the right numerical answer. Okay. If you can't tell me how far 1 mile minute per hour is, I'm not going to let you use them on your work. Okay. So instead of doing this, I would say, no, minutes isn't going to work here. I need to make sure to change my units into hours. Or you could change your miles per hour into miles per minute. That would work as well. But typically this is the easier translation. All right, I've made this one kind of long, so we'll go on to the next.